Hi there, I'm Scott from Freescale, and today we're going to take a look at the QE08 device and how low power we can get with this. If you take a look at the example projects in CodeWarrior 6.2, you'll actually find the software we're going to be looking at today. And then I'm going to introduce a couple of additional projects that will show just how low we can go. So all I'm using today is my laptop with CodeWarrior 6.2 installed. I've got the QE8 demo board, or the demo QE, which actually uses the QE128 and the QE8, and then just a digital multimeter that's going to give me some accurate measurements all the way down into the nanoamp range. So the first thing we're going to do is we're going to take a look at the QE8 low power lab, take the part through some different modes, show what kind of currents we're drawing on average, and give you an idea of some techniques you can use to maximize your power consumption in your application. So right now I've taken the board, I've actually taken some jumpers off of it, in particular the one that connects to this analog pot, and just to make sure that we're getting as low current as we can on this. So I've already programmed my part with the lab. When I've got my computer running, I'm going to go ahead and close the debugger to make sure it's not trying to communicate with the part. I'm going to open up this terminal window that is going to talk to the part through the USB, and I'm going to go ahead and open that port up. Now I'm going to reset my board so that it starts running the code. And so right now the device is kind of in a normal run mode where it's giving me the menu on the display here, it's taking me through the terminal window, and it's just doing a count every 5 seconds. And if we take a look over the digital multimeter, we can see that the part is burning about 4.5 milliamps, and this is in normal run mode. So the first thing we're going to do is take the part into a low power run mode where we really just start to run off the crystal that's outside the part and take it as low as we can go, using a loose regulation inside the part to get as low power as possible. I'll do that by pushing the PTA 3 button. As you can see, we've entered the low power run mode. It's going to update that on my terminal utility. We shut off the time updates, but it is still keeping track of that time. And we can see that we've actually dropped down to about 22 microamps. So quite a difference going from normal run mode to low power run mode. Now let's keep in mind we are running at a slower speed here. We're at 16 kilohertz bus versus 10 megahertz bus in a normal run mode. We'll jump back into normal mode so we can try some of these other modes. So right now we're back in normal run mode. If you do take a look at the screen real quick, you can see that the count has been keeping track of where we're at. So we're about 1:15, whereas we went into low power in about 30 seconds. Now I'm going to jump into stop 3. And I'll do that by hitting the button here, I believe it's PTD2. That will take me into stop 3. You can see that on the terminal. I'm still going to wake up and update my count and the display every 5 seconds. And you can see that the average current here is about 1.5 microamps, or 1.4, a little less. So let's take it even lower and go into stop 2. First I'll need to jump back into normal run. Alright, so I'm back in normal run. So you can see we're about 4.5 milliamps again. Now let's jump into stop 2. Alright, we've jumped into stop 2. You can see it's updated on the screen there if you want. But you also take a look and we're even lower on the stop current there. And keep in mind this is an average. We're still waking up every few seconds to update everything. And so this 1.2, 1.27 microamps includes the stop current and the wake up current. That's just an average measurement there. So the last thing we're going to do is we're going to get back into normal run mode, and we're going to show you a feature on the QE8 called clock gating. And what this does is it basically shuts off the clocks to any unused peripherals, so that we're kind of lowering the overall chip power consumption. So I'm going to do that by hitting the reset button here. You can see in my terminal that we've gone into the clock gating, we've enabled it, our run currents are lower. And if you take a look, we went from 4.5 to about 3.5 milliamps. So quite a significant difference there, depending on what your system is doing. Now, we're going to take a break for a second, and I'm going to load up some code that's going to take us into stop 2 and stop 3 modes, where we are just going to stop mode. We're not going to wake up, and we're going to see absolutely how low power this part really is. Alright, we're back. So far, I've loaded some code that all it's going to do is put this part in stop 3, and we're going to measure the current at what it is when the part's actually in stop. So I've already loaded that with my CodeWarrior 6.2. It's in a run mode right now. Obviously not doing much because we're only at 2.2 milliamps. As soon as I push my PTA2 here, we're going to go into a stop 3. So as you can see, we're at about 280 nanoamps for a stop 3. So that's a very good number there. Now I'm going to take us into some code that's going to drop us into stop 2. Alright, so now we've got the part loaded with some code that's going to put it into stop 2. So again, we're in a run mode at 2.3 milliamps. I'm going to go ahead and hit my button to put it in stop 2. And as we can see, we're even lower than we were in stop 3. This will settle out at about 235 nanoamps. So pretty good power consumption there. To get all this code, you can download the QE Low Power Lab from the web, or it's also available within CodeWarrior 6.2. You just download that. It is part of the evaluation board demos. The stop 2 and stop 3 code was really just kind of a quick thing that I jotted down. To let you know what I did though, set all the IOs up as inputs with pull-ups enabled, and that's going to allow me to get the lowest power possible.